Have you ever wondered what a geologist might see when looking at Mars? This captivating red orb in our night sky has been a source of intriguing and fascinating planet for centuries. But it is not just its striking color that tantalizes our curiosity. Mars, our celestial neighbor, presents a unique opportunity for geologists to extend their study beyond the confines of our own planet. Imagine the thrill of analyzing another terrestrial planet, a world with its own unique geological narrative. Mars is a geologist's dream, teeming with features that pique their interest. Its surface, a tapestry of craters, canyons, and volcanoes, tells a tale of geological activity and climatic shifts. Beneath this, the crust holds secrets of this planet's past, a chronicle of billions of years etched in rock. The allure of this planet extends far beyond its ruddy hue. It's a geological treasure trove waiting to be explored, so let's delve deeper into the intriguing geological features of Mars. Firstly, we must address the most distinctive feature of Mars, its surface. This celestial body, famously known as the Red Planet, owes its signature hue to the omnipresent iron oxide, or more commonly, rust, that blankets the surface of the planet. This iron oxide not only paints Mars in its characteristic reddish tint but also plays a crucial role in the planet's geology and our understanding of this planet. The surface of Mars is not just a static, monotonous expanse, it's a dynamically changing landscape, mirroring the shifting sands of the Earth's deserts. Martian dunes, shaped by the planet's thin atmosphere and strong winds, dance across the surface, creating an ever-changing topography. These dunes, in their various forms, crescent, linear, and star, actually offer fascinating insights into the Martian wind patterns and atmospheric conditions. Mars also boasts a dramatic assortment of craters, remnants of its tumultuous past. These craters, like time capsules, hold stories of cosmic collisions and powerful eruptions. Their sizes and distributions provide crucial clues to the planet's geological history and surface evolution. But the Martian surface is not all about barren landscapes and rusted soil. It is punctured by polar ice caps, much like Earth. These caps, composed of water and carbon dioxide, wax and wane with the Martian seasons, representing an active and ever-evolving climatic system. Yet, the crowning jewels of the Martian surface are without a doubt Olympus Mons and Valles Marineris. Olympus Mons, the tallest volcano in the solar system, towers above the Martian surface, a testament to the planet's volcanic activity. Meanwhile, the other one is a Grand Canyon system that dwarfs our own Grand Canyon, stretches across the Martian equator, revealing layers of Martian history etched into its walls. These features alone make Mars a geologist's dream, but there's more beneath the surface. As we go deeper into Martian geology, we will uncover secrets locked within the crust, mantle, and the core of this red planet, each layer holding keys to unraveling the mysteries of Mars. Now, let's journey beneath the surface and explore the crust of this planet. The crust of Mars is actually a fascinating study. In contrast, on Earth, our crust varies in thickness, ranging from about 3 miles beneath the ocean surface to around 30 miles beneath our mountain ranges. Mars, however, presents a more unified front. Its crust is uniformly thick, averaging about 50 miles across the entire planet. This makes it almost twice as thick as Earth's average crust thickness. But the differences don't stop there. Earth's crust is divided into tectonic plates, those enormous slabs of rock that float on the mantle below and give rise to our earthquakes, volcanoes, and mountain ranges. But what about Mars? Mars doesn't have the tectonic plates. Its crust is actually a single solid shell. This indicates a lack of internal activity, suggesting that Mars probably is geologically dormant, at least compared to Earth's dynamic, ever-shifting surface. So what is this Martian crust made of? Well, just like Earth, The crust of this planet contains a mixture of elements. Silicon and oxygen are the most abundant, but there's also a good amount of iron, magnesium, aluminium, calcium, and potassium. This composition is similar to Earth's continental crust, but with a notable difference. Mars has a higher concentration of iron, which gives the planet its distinctive reddish hue. The presence of these elements tells us a lot about Mars' past. For instance, the abundance of silicon and oxygen suggests that Mars, like Earth, once had active volcanoes that spewed out molten rock or magma. This magma would have cooled and solidified to form the crust we see today. The iron and magnesium in the crust, on the other hand, hints at a more complex story. These heavier elements normally suggest that Mars' crust was formed from a magma ocean, a vast sea of molten rock that once covered the planet's surface. The crust is just the beginning. Deeper still, we find the mantle and core. With every layer, we unravel more of Mars' geological history, a testament to the planet's dynamic past and possibly its potential for future exploration. Venturing deeper into Mars, we encounter the mantle and core. The mantle, the planet's second layer, is a thick, rocky shell making up the majority of Mars' volume. But unlike Earth, the Martian mantle is thought to be more viscous or resistant to flow. This is due to its composition of silicate minerals, just like Earth, but in different proportions. This increased viscosity could explain why Mars doesn't experience plate tectonics like Earth does. Now let's plunge even deeper to the heart of this planet, the core. The size of Mars' core remains a topic of scientific debate. Some estimates place its radius anywhere from around 1000 to nearly 2000 kilometers. But what's really inside? Is it solid or liquid? Again, there is no consensus. However, many scientists lean towards a partially molten or liquid core. Yet, one thing is certain, Mars lacks a global magnetic field. This is likely due to its core not being active enough to generate one, unlike Earth's molten outer core. This lack of a magnetic field has profound implications for Mars' atmosphere. Without this protective shield, solar winds have gradually stripped away much of Mars' atmosphere over billions of years. From surface to core, Mars is a treasure trove of geological wonders. So, to sum up, Mars presents a fascinating study in geology, from its intriguing surface marked by vast plains and towering volcanoes to its crust bearing the scars of meteor impact. Deeper still, we find a mantle and core that hint at the planet's turbulent past. Ongoing research and future missions continue to peel back the layers of Mars geology, promising further exciting discoveries. So the next time you gaze upon at the night sky and spot the red glow of this planet, remember the geological wonders that lie beneath its surface. So with that, signing off, and don't forget to subscribe.